Hello students, welcome back to the Tantray Sir Physics classes. Today we are starting rotational dynamics. It is the first lecture on rotational dynamics and it will take us number of lectures. I don't know how many lectures it will take me to complete this whole rotational dynamics. And every lecture will be followed by a problem set. You have to closely watch the lecture series so that you can understand it in a very nice, good way. You can't skip the lectures. You have to be consistent with the lectures if you want to learn it thoroughly. Okay, the first lecture on this rotational dynamics, I will start with center of mass. Because in rotational dynamics, center of mass is a very important concept. Then once we understand center of mass concept, then we can go ahead with the rotational dynamics. This is very basic. Center of mass concept. So, number one, center of mass. Center of mass concept. What is this? What is the center of mass of an object? Every object, every body has a particular point within the body, or it may even be outside the body, जिसको हम center of mass कहते हैं. एक बॉडी है, इस बॉडी के अंदर पॉइंट हो सकता है या इस बॉडी के बाहर कोई पॉइंट हो सकता है जो हम कहेंगे ये बॉडी का सेंटर ऑफ मास है. सो हाउ इट इज डिफाइंड, कैसे मैं डिफाइन सेंटर ऑफ मास को करूंगा, इसका क्या है इसकी इंपॉर्टेंस. सी हियर, इफ आई हैव एन ऑब्जेक्ट हियर, इट इज एन ऑब्जेक्ट हियर एंड आई अप्लाई फोर्स F on this object and its mass is M. If I ask you what is the acceleration of this body, what is your answer? There is no friction, let me suppose. You are applying force F on this body of mass M, and I ask you a question, what is the acceleration of this body? Your answer is acceleration of this body, A, is this F, force divided by this mass. That is your answer. And we always say acceleration of the whole body. We don't say acceleration of this point, this point, this point, or any point inside the body. We say just the acceleration of the body. Because all the points of the body have the same acceleration. That's why we say acceleration of the body. The different points of the body don't have different accelerations. It is a pure translational motion. In pure translation motion, all the points of the body move with the same acceleration. हर एक पॉइंट जो है बॉडी का, उसका एक्सेलरेशन वही है, ये वाला, ये एक्सेलरेशन. तो देन वी से एक्सेलरेशन ऑफ द बॉडी. वी वेरी राइटली से एक्सेलरेशन ऑफ द बॉडी. ओके, नाउ लेट मी टेक अनदर एग्जांपल. This body has a pure translation motion that we have done so far in mechanics. Only translation motion. The whole body has the acceleration A. All the points of the body has acceleration A, and acceleration of the body is just net force on the body, that is F by M. Here is the only force applying, that's F by M. But if there are so many forces, then we have to find the net force. Net force divided by mass is the acceleration of the body. ठीक? अच्छा. Now let me take a rigid body. Any other rigid body. This is the rigid body. And I apply force here. What happens to this body? Let me suppose the mass of the body is M. What happens to this body? It does not have a pure translation motion. It also rotates. And if it is a sphere, and it has a better chance of rotation, you apply force here. Apply force here. This body has a possibility of rotation also. This body has also a possibility of rotation. But this body was not having a possibility of rotation. There was no friction and it will straight go in the forward direction, and its acceleration is A. The whole body has acceleration A. All the points of the body has acceleration A. Therefore, acceleration is equal to F by M. But now the question is, what is the acceleration of this body? Or what is the acceleration of this body? It is useless to say acceleration of this body. क्योंकि इस body में हर एक point का acceleration same नहीं होगा. इस पॉइंट, इस पॉइंट, इस पॉइंट, इस पॉइंट, जो भी जितने भी पॉइंट्स इस बॉडी के अंदर है, उनका एक्सेलरेशन सेम नहीं होगा, क्योंकि इस बॉडी का ये ट्रांसलेशन प्योर ट्रांसलेशन नहीं है, इसका रोटेशन का भी है. It has a possibility of rotation also. और इस बॉडी का भी यही हाल है कि all the points, different points of the body do not have the same acceleration. So to say the body acceleration is F by m is useless, or to say body acceleration is F by m is useless. So what we do is that इस बॉडी का एक पॉइंट ऐसा जरूर है, एक पॉइंट इस बॉडी के अंदर ऐसा एक पॉइंट जरूर है जिसका एक्सेलरेशन F by m है। इस बॉडी के अंदर भी एक पॉइंट ऐसा जरूर है, वो पॉइंट है, कोई पार्टिकल नहीं, पॉइंट है। इस बॉडी के अंदर एक पॉइंट ऐसा है जिसका एक्सेलरेशन F by m है, और इस बॉडी के अंदर भी एक पॉइंट ऐसा होगा जिसका एक्सेलरेशन F by m है। दैट पॉइंट वी कॉल ए सेंटर ऑफ मास। सो देयर इज ऑलवेज अ पॉइंट इन द रिजिड बॉडी whose acceleration is net force on that body divided by mass. तो वो पॉइंट, अगर ये वो पॉइंट है तो इस पॉइंट का एक्सेलरेशन जो है वो F by m है। अगर आपको पूछा जाए व्हाट इज द एक्सेलरेशन ऑफ दिस पॉइंट, you don't know, we don't know of the acceleration of different points of the body except this point. This point has the acceleration F by m. तो वो पॉइंट जिसका एक्सेलरेशन F by m है, net force on the body divided by mass is the acceleration of that point in the body. जिस पॉइंट का ये एक्सेलरेशन है, समझो वही सेंटर, वो that is called a center of mass. तभी तो बुक्स में लिखा होता है it is the total mass of the body is concentrated there. और जैसे आपने फोर्स भी उसी पॉइंट पर अप्लाई किया और एक्सेलरेशन भी उसी पॉइंट का हो गया F by m. That's why in most of the books what is written as that is the point where total mass is supposed to be concentrated. जैसे सारा मास यहीं पर है और फोर्स भी आपने वही अप्लाई किया और उसी पॉइंट का एक्सेलरेशन हुआ F by m. So now what is center of mass? Center of mass is a point whose acceleration is net force by mass. What's the acceleration of different points of the body? That we have to see. That we will possibly at the last lecture I will tell you what is the acceleration of different points of the body, because for that we have to find the torque by this force. There is a different lecture, but फिलहाल तो ये है कि वो पॉइंट जिसका एक्सेलरेशन F by m है, that is the center of mass. So center of mass definition कुछ ऐसे मैं अब डिफाइन करना चाहूंगा। सेंटर ऑफ मास जो है उसको ऐसे हम डिफाइन अप करेंगे, द सेंटर ऑफ मास इज अ पॉइंट whose acceleration is F net by mass. और जैसे किताब में डिफाइन भी किया होता है, इट इज द पॉइंट वेयर टोटल मास इज सपोज्ड टू बी कंसंट्रेटेड। वो पॉइंट है जहां सारा मास लगता है कि वही सारा मास है। इट इज एज इफ टोटल मास इज देयर एट दैट पॉइंट, और फोर्स भी वही आपने अप्लाई किया एज इफ, एंड उसका एक्सेलरेशन हो गया F by m. और द पॉइंट वेयर टोटल मास of the body is supposed to be concentrated. मतलब बॉडी का बिहेवियर कुछ ऐसा होता है जैसे सारा का सारा मास एक खास पॉइंट पर कंसंट्रेटेड है, जिस पॉइंट को हम कहते हैं सेंटर ऑफ मास। ओके, दिस इज द डेफिनेशन ऑफ सेंटर ऑफ मास. Again, there's a rigid body, you apply force, and the body has a tendency of rotating also, translating also. Then different points of the body don't have the same acceleration. There is a particular point of the body whose acceleration is F by m, where F is the net force acting on the body. That's all. Okay, now point number second. Point second is, now the question is, where is this point? Where is this point, center of mass point of rigid bodies? तो वो लोकेट करना पड़ेगा। एक रिजिड बॉडी है, मुझे कहां पता है इस बॉडी के अंदर किस पॉइंट पर सेंटर ऑफ मास है। अगर मैं फोर्स दूंगा, फोर्स अप्लाई करूंगा, तो किस पॉइंट का एक्सेलरेशन F by m होगा? हाउ डू आई नो? सो फर्स्ट ऑफ ऑल लेट अस गो इन अ सिंपल examples. We'll pick up simple examples. जैसे rigid bodies है लेकिन symmetrical है, symmetrical bodies, center of mass of symmetrical bodies. center of mass of symmetrical bodies. Symmetrical bodies like a sphere, a ring, a rod of uniform mass density, a triangle, equilateral triangle, they are symmetrical. These are called symmetrical bodies. The center of mass of all the symmetrical bodies are at their geometrical centers. जो उनका geometrical center होता है वही center of mass होता है. जैसे sphere है, solid sphere, solid और hollow, solid एवं hollow, उसका center of mass यहां है, geometrical center. अगर रिंग है, इसलिए मैंने कहा कि center of mass है point, इट इज नॉट द पार्टिकल. अगर ये हॉलो है तो हॉलो के अंदर एक स्पेस पॉइंट होगा, मैथमेटिकल पॉइंट, वहां कोई मटेरियल तो है नहीं, तो इसलिए सेंटर ऑफ मास कोई पार्टिकल नहीं है, सेंटर ऑफ मास है पॉइंट, मैथमेटिकल पॉइंट. ये स्फीयर है तो ज्योमेट्रिकल सेंटर यहां है तो वही सेंटर ऑफ मास है. अगर रिंग है तो वही सेंटर पर है. अगर रॉड कुछ ऐसे है, मतलब सिमेट्रिकल है, तो सेंटर ऑफ मास इधर है. It can even balance at the center of mass. Center of mass पर ये रॉड बैलेंस होगा, ग्रेविटी से बैलेंस होगा. अगर ये इसका सेंटर ऑफ मास ढूंढना है तो मैं इसको बैलेंस करूंगा, उस पॉइंट पर मैं इसको ऐसे बैलेंस कर सकता हूं. उस पर बैलेंस कर सकता हूं. बिकॉज ग्रेविटी विल बैलेंस, ग्रेविटी ड्यू टू दिस बॉडी विल बैलेंस अंडर ग्रेविटी फोर्स एट द सेंटर ऑफ मास. Because center of mass is also a center of gravity here, closer to the surface of the earth. Okay. अगर ये ट्रायंगल है, ऐसे इक्विलेटरल ट्रायंगल है यूं, तो सेंटर ऑफ मास बीच में, सेंटर पर, ज्योमेट्रिकल सेंटर पर. अगर सिलेंडर है, सॉलिड हो या हॉलो हो, तो सेंटर पर है. तो इन शॉर्ट व्हाट आई वांट टू से इज दैट फॉर ऑल सिमेट्रिकल बॉडीज द सेंटर ऑफ मास लाइज एट देयर ज्योमेट्रिकल सेंटर्स. That's all. I will write it down. The center of mass of all symmetrical bodies the center of mass of all symmetrical bodies the center of mass of all symmetrical bodies is at their geometrical centers. जो ज्योमेट्रिकल सेंटर होता है रिजिड बॉडीज का, सिमेट्रिकल बॉडीज का, जो उनका ज्योमेट्रिकल सेंटर है वही सेंटर ऑफ मास होता है. अगर ये रिंग है, ये मास रिंग पर है, लेकिन सेंटर पर तो कोई मास भी नहीं है, तो सेंटर ऑफ मास यहां देखो. और अगर फोर्स आप यहां अप्लाई करेंगे, सपोज इसका मास m है, तो व्हाट इज द एक्सेलरेशन? ये कहना है कि व्हाट इज द एक्सेलरेशन ऑफ द रिंग इज मीनिंगलेस, because there are different points of the ring which have different accelerations, but this point has an acceleration of f by m. That is all. तो जिस पॉइंट का एक्सेलरेशन f by m होगा तो वही सेंटर ऑफ मास कहलाएगा. ठीक? Okay. Now, point third, how to locate the center of mass of two body system. अगर मेरे पास दो बॉडीज है, पॉइंट मासेस है. Third, location of center of mass. Center of mass of two body system. Of two body system. तो कैसे दो बॉडीज का सेंटर ऑफ मास निकाला जाएगा? लेकिन दो बॉडीज जो है ना, दे आर सिमेट्रिकल बॉडीज and you already know the center of mass of individual bodies. लेकिन दो बॉडीज का टोटल सेंटर ऑफ मास कहां है? The center of mass which belongs both the bodies. जैसे ये दो बॉडीज है, इसका मास समझो m1 है, इसका मास समझो m2 है, तो मुझे इन दो बॉडीज का सेंटर ऑफ मास चाहिए. टुगेदर एज ए सिस्टम। लेकिन देखा जाए कि अगर इस m1 का सेंटर ऑफ मास चाहे तो वो इसके सेंटर में है, ऐसे अगर इस बॉडी का चाहे तो वो इसके सेंटर में, लेकिन दोनों बॉडीज का टुगेदर सेंटर ऑफ मास कहां है, कैसे लोकेट करेंगे? तो याद रखने की बात यह है कि द सेंटर ऑफ मास ऑफ टू बॉडी सिस्टम लाइज ऑन द लाइन ज्वाइनिंग देयर सेंटर्स। अगर इनके दो सेंटर्स को ज्वाइन किया जाए तो इन दो का सेंटर ऑफ मास इसी लाइन पर लाई करता है, चाहे यहां हो यहां हो यहां हो, कहीं इस लाइन पर है। जब आप दो बॉडीज को एक लाइन से ज्वाइन करोगे तो दो बॉडीज का जो सेंटर ऑफ मास है इसी लाइन पर होगा, ठीक। लेकिन अगर जिसका मास ज्यादा होगा तो सेंटर ऑफ मास उसी के ओर शिफ्ट होगा। सपोज सेंटर ऑफ मास यहां पर है, इस पॉइंट पर, तो वैसे अगर ये थिन रॉड से मैं कनेक्ट करूंगा तो दीज टू बॉडी शुड बैलेंस ड्यू टू ग्रेविटेशन, वो ग्रेविटेशन से बैलेंस होगा। आई मीन इफ दिस इज, ये दो पॉइंट जो मैंने कनेक्ट किए लाइन से, अगर मैं इनको कनेक्ट करूंगा सपोज एक थिन मासलेस रॉड से, थिन मासलेस रॉड, तो फिर यहां पर ये बैलेंस भी हो सकते हैं, दे कैन बी बैलेंस्ड ऑन दिस वेज इफ इट इज द सेंटर ऑफ मास। सपोज यहां से यहां ये x1 का डिस्टेंस है और ये सेंटर ऑफ मास m2 से x2 दूरी पर है, तो देन द रूल इज m1 x1 इज इक्वल टू m2 x2। वो कैसे? जैसे ये इस पर फोर्स ग्रेविटी की वजह से m1g है और इस पर फोर्स से ग्रेविटेशन की वजह से m2g, तो m1g into x is moment from the left side, m1g into x1 is moment from this side, it should be equal to moment on that side, m2g x2। वजह यह है कि it will balance, it will not tilt either way। When it balances, that means this torque is equal to this torque, or this moment is equal to this moment. What is moment? Force into force arm, force into this arm, force into this arm. Moment from this side, this force into this arm, moment from this side is force into this arm. Okay, now g will cancel with g, so m1 x1 is equal to m2 x2. This is the rule. If m1 is heavier, if mass is very very heavy, then center of mass will shift towards this greater mass side, so that m1 x1 is equal to m2 x2. This is more, this should be less, this is less, this should be more, so that equation is m1 x1 is equal to m2 x2. This is the rule when we want to find the center of mass of two body system. What we do is we get the two bodies, join them by a line, and center of mass lies on that line, and center of mass is closer to the heavier mass side. जो mass heavier होता है तो center of mass उसी की ओर shift हो जाता है। Okay, now fourth point, चलो मैं निकाल ही देता हूं, कुछ एक एग्जाम्पल देना चाहूंगा दो बॉडी सिस्टम के लिए। लेट मी गिव एन एग्जाम्पल ऑफ टू बॉडी सिस्टम। फोर्थ, ये एक बॉडी है, इसका 10 kg का मास है, 10 kg का मास है, और ये दूसरा बॉडी है सपोज 100 kg का मास इसका है, और इनके दरमियान डिस्टेंस ओके 10 मीटर्स, सेंटर, इस सेंटर और इस सेंटर के दरमियान 10 मीटर का डिस्टेंस है। My question is, where is the center of mass? Obviously, that center of mass should lie closer to this mass. That should lie close because this is 100 kg. Center of mass इसी को shift होगा. Okay, let it shift over. Let it be here somewhere. Suppose this is x1 distance, and what is this? X distance. Why x? X1, x distance. So what should be this remaining distance? That is, yes, 10 minus x. I want to find this x. Where is the location of center of mass? How much it is away from the heavier mass, or how much away it is from the lighter mass? You can find x, and then obviously you can find 10 minus x. So that's my question. So what's the rule? This mass m1 x1 is equal to m2 x2, but m1 is 10 kg and x1 is 10 minus x is equal to, what's m2? That's 100 into what's x2? That's x. So it is 100 minus 10x is equal to 100x. Get this over to that side. This 100 is equal to 110x. So what is x? 100 by this 110. This will cancel off. So 10 by 11 meters. It is 10 by 11 meters. 10 by 11. How much should be this? 10 minus 10 by 11. That you can find. You can find this, you can find this. So the rule is this mass into this distance is equal to this mass into this distance. M1 x1 is equal to M2 x2. Okay, that's one point. Fifth point. Don't forget that what we are doing. We are defining center of mass of rigid bodies, and we try to locate the center of mass of many body system. फिलहाल तो दो bodies का center of mass मैंने locate किया. We should be able to locate center of mass of many body system. There may be 100 bodies, 4 bodies, 5 bodies. We should be able to locate their center of mass. Why lies their center of mass? If you apply force anywhere, is the center of mass which will get the acceleration. That external force divided by all the masses of the bodies, total mass of all the bodies. Fifth point. Can we do this? Suppose it is 5 kg or it's 10 kg here, and the distance is okay, 5 meters. Can I find the center of mass? But the center of mass should be shifted to the greater mass side here. Okay, let it be this position of the center of mass. Let it be x away from here. And how much is this? 5 minus x. If 5 is the distance between the two centers, then obviously if x is this, then the remaining distance 5 minus x. So what is the formula that you are going to use? कौन सा formula use करेंगे to locate the center of mass of this two body system? It will be 5, this mass into this distance, 5 minus x, 10 into this x. This 25 minus 5x is equal to 10x. So it is 25 is equal to 15x. X is equal to 25 by 15. It is 5 by 3. 5 by 3. So it is 5 by 3. And you can also find the remaining distance. 5 minus 5 by 3, remaining distance can also be found. And you can find where is the location of the center of mass, how much away it is from the larger mass side, or even how much away it is from the smaller mass side. Okay, now let me go to how to locate the center of mass of multi-body system. More number of bodies. How we can do that? Let us try to understand that. If I ask you what we mean by locating the center of mass of multi-body system, 2, 4, 7, any number of bodies, the answer is we have to locate its coordinates. Where is the center of mass means where it is center of mass means what are its coordinates. If I ask you where I am, where is my position, you can't say that you stand just here. You will say that your coordinates are 2 and 3, 4, 7 on the surface. So if you want to locate any body's position, you have to locate its coordinates. And the individual bodies जिनका मुझे सेंटर ऑफ मास निकालना है, जो बॉडीज का मेरे पास है बॉडीज, उनका मुझे जो सेंटर ऑफ मास निकालना है, उन बॉडीज का कोऑर्डिनेट्स दिया होना चाहिए. Their location must be given to find the location of the center of mass of all the bodies together. So, sixth point, center of mass of many body system. ये कहाँ है सेंटर ऑफ मास जो बहुत सारे बॉडीज को मैं टुगेदर लाना चाहता हूँ. There's something like this. It's a coordinate system. It is x, it is y, and this is z coordinate in the outward direction. This is the body of some mass m1. Okay, let the mass m2. It is mass m3, and so on. There are so many masses. What are its coordinates? Okay, what is its radius vector? How much away it is from the origin? R1, let me suppose. Vector. It is R2. It is R3. Vector. I am giving the radius vectors of these three masses. There may be many other masses also. So where is the center of mass? Maybe center of mass is somewhere here. I have to locate the center of mass of this point. That is okay, RCM. ये मुझे how much away this center of mass is away from the origin. इन सारे बॉडीज का सेंटर ऑफ मास यहां समझो. अब मुझे ये निकालना है ये RCM जो है सेंटर ये ऑरिजिन से ये RCM how much away the center of mass is from the origin. मतलब what is this position vector? What is the position vector of the center of mass of all the multiple bodies? मैंने यहाँ 3 bodies दिखाए लेकिन there may be other bodies also. So what is this RCM? RCM. What is this? That is the question. All the bodies have their coordinates are given. RCM radius vector हो या coordinates one and the same thing, because R1 is given, that means x1, y1, z1 is given. Because this R1 is vector x1i plus y1j plus z1k. If you are given R1 vector, that means you are given the coordinates x, y, and z. What is RCM? What is the center of mass of all these bodies? If you apply force on any body, or 2 bodies, 3 bodies, you find a resultant of all those forces. The acceleration of this point, center of mass, will be sum of all those forces divided by sum of masses. That is the meaning of the center of mass. You apply forces, find the resultant force, divided by total mass. It is the center of mass which will get acceleration. F net by m. F net is all the forces acting on all the bodies, and divided by mass, all the masses put together, divide in the denominator. What are the accelerations of individual bodies? That you have to find separately. Now, radius vector of the center of mass is given by m1 r1 plus m2 r2 plus so on divided by total mass. Answer. This is the answer. M1, it is radius vector. M2, it is radius vector, plus M3, it is radius vector, plus M4, it's the divided by sum of the mass. M1 plus M2 plus M3 plus M4, that's total mass. If I write here M1 plus M2 plus M3, M3 R3 vector plus so on. This is the answer. If I ask you what is the x coordinate of the center of mass, XCM is equal to M1 x1, x coordinate of this object, this mass, plus M2 x2 plus so on divided by total mass. What is YCM? Y coordinate of the center of mass. M1 x1 y1 plus M2 y2 plus so on divided by total mass. What is ZCM? If the center of mass is in space, then it has 3 coordinates. That will be M1 z1 plus M2 z2 plus so on divided by mass. This is the rule. That's all. Okay, let me give you some examples. 6th, 7th point. Let me give you some examples on this. Suppose it's a coordinate system, say x and y, and here it's a square type geometry. It's a mass here m, it is mass here m, it is 2m here, it is 2m here. These are 4 masses, and I have to find the coordinates of the center of mass of this system of 4 masses. What are its coordinates? So I have to locate the coordinate of every mass first, every object. What is the coordinates of this mass? 0, 0. What's coordinates of this mass? This length is A, and A. What is the coordinates of this? It's A is x, 0, y. What is coordinates of this? A, x coordinate A, y coordinate also A. What is here? 2m. X coordinate is 0 and y coordinate is A. So first of all, you need to locate the center of mass. You need to locate the coordinates of all the objects. all the masses whose center of mass you want to locate. Okay. Now, what is the x coordinate of the center of mass? XCM. Write down the formula first so that it becomes easy. M1 x1 plus M2 x2 plus M3 x3 plus M4 x4 divided by total mass. XCM is equal to, okay, what is M1? Start from here. M1, M2, M3, M4. Counting from here. M1, that is M. What is this coordinate? X coordinate, that is 0. Plus M2, that is M. What is the X coordinate? That is A. What is M3? That is 2M. What is this X coordinate? That is A. What is M4? That is 2M. What is its X coordinate? That is 0. Divided by total mass. M, M, 2M, 2M, M, M, 2M, 4, 6M. This goes and this also goes. Now, what is XCM? That is 2 and 3 MA by 6M. This cancels. A by 2. Answer. X coordinate is A by 2. So similarly, you can locate the Y coordinate. So X coordinate is somewhere here. This is the X coordinate. X coordinate. Let me find the Y coordinate. YCM. M1 Y1 plus M2 Y2 plus so on divided by total mass. So what is YCM? You can substitute. YCM is equal to, what is M1? That is M into 0. What is M2? That is M into 0 again. What is M3? 2M into A. What is fourth particle? 2M. What is this Y coordinate? That's A. Divided by M, 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 2M, 4, 6M is equal to, this goes and this goes. It is 4MA by 6M. This cancels. 2 and 3. 2A by 3. So center of mass का जो location है, XCM is equal to A by 2 and YCM is equal to 2A by 3. This is the location of the center of mass. A by 2, X coordinate is A by 2 and Y coordinate is what? 2A by 3. ये center of mass यहाँ पर है, वहाँ कोई particle नहीं. What's the base point? That's all. Eighth example. चलिए, okay. Eighth example. Suppose again I take a coordinate system and a triangular shape, geometrical shape. It's X and Y and Z. Okay, it is called 0 origin. Here's a mass. Here's a mass and here's a mass. Okay, for simplicity, M, M and M. I want to locate the center of mass of 3 body system. लेकिन है तो सिमेट्रिकल, M, M, M तो सेंटर में ही होगा, लेकिन हम फिर भी निकालते हैं. देखिए इसका कोऑर्डिनेट क्या है, इस मास का 0 0 0 ऑरिजिन पर है. इस कोऑर्डिनेट, सपोज ये लेंथ L है, ये L है, ये भी L है, तो इसका कोऑर्डिनेट है पहले ये L डिस्टेंस, वो x हो गया, तो y x एक्सिस पर y कोऑर्डिनेट 0. अब इसका क्या है, इसका x कोऑर्डिनेट इतना है, इसका आधा, दैट इज L by 2. इसका y कोऑर्डिनेट क्या है, तो वो निकाला जा सकता है. अगर ये 60 डिग्री है तो ये L का ये कंपोनेंट है L cos 60, दैट इज L by 2, तो ये है L sin 60. तो ये L है ना, तो इस L के 2 पीसेस कर दो. ये वाला पीस है L cos 60, दैट इज L by 2, और ये वाला पीस है L sin 60, दैट इज L root 3 by 2. So at least what I did is that I located the coordinates of every mass point. So now what is the center of mass coordinate XCM? Write down the formula in a very cool manner, m1x1 plus m2x2 plus m3x3 divided by sum m1 plus m2 plus m3. This is the basic formula, base formula. So what is xcm in the present case? इस केस में क्या है, क्या लिखेंगे xcm? पहले ये m लीजिए m1, उसका x कोऑर्डिनेट 0 प्लस फिर ये लीजिए m2, उसका x कोऑर्डिनेट l, फिर ये लीजिए m थर्ड, उसका x कोऑर्डिनेट l/2 बाय m 3m। तो xcm किसके बराबर? ये 0 हो गया, ये 2 और ये 3/2 m l. If you add these two, it will be 3/2 ml by 3m. 3m gets cancels l/2. तो x कोऑर्डिनेट यहां पर इसी लाइन पर होना चाहिए, l/2 उसका कोऑर्डिनेट है। लेकिन y कोऑर्डिनेट क्या होगा? व्हाट इज द y कोऑर्डिनेट? ये वाला इतना डिस्टेंस, ये डिस्टेंस निकाला, l/2 इसका कोऑर्डिनेट, इस पॉइंट का कोऑर्डिनेट ये x कोऑर्डिनेट है, होना भी चाहिए l/2 और निकला भी l/2। लेकिन व्हाट अबाउट y कोऑर्डिनेट? यस, m1 y1 plus m2 y2 plus m3 y3 divided by total mass. Now substitute the values for m1, m2 and m3. What you are getting? अगर m1 को substitute किया जाए तो m है, m2 m, m3 m. लेकिन अब y1 is this 0. For first particle the y coordinate is 0. For the second particle y coordinate is again 0. Only third particle has some y coordinate. So why not to write it like this? YCM is equal to, it is 0. No. It is m into 0 plus it is m into again this 0 plus m. What is this y coordinate? L√3/2 whole divided by 3m. So what is YCM? Yes, 0 0 khatam. So ye m gets cancelled. So what should I write? So L√3/6. 3 to the 6. It is 3 into 2. It is L by 2√3. What you do is rationalize it. √3 और √3 मल्टीप्लाई कीजिए, ऊपर 3 होकर के ये ऐसे हो जाएगा, यूं आपको इक्वेशन मिलेगा. So I have located the center of mass. So this is the rule of locating the center of mass of multi-body system. I will continue with the center of masses in maybe 1 or 2 lectures, so that you become very familiar with how to locate the center of mass of multi-body systems, rigid bodies, extended bodies, non-uniform bodies, where density differs. How can we locate the center of mass? So it takes a few lectures so that we become very familiar with what we are doing. So lastly, I again ask you to download my app, Nazir Physics Classes. And also there's a whole lot of literature available there. वहाँ बहुत सारे questions आपको मिलेंगे जिनको करने से आपका और प्रैक्टिस होगा. और फिर YouTube पर मेरे लेक्चर आते रहेंगे, तो YouTube का वो जो चैनल है वो सब्सक्राइब करके आप लेक्चर घर बैठे बैठे देख लो, and prepare from your own places. And also if you have additional problems, you can just on the comment section you can ask me problems, so that those problems can be discussed in the course of the lectures. Thank you.